So this is a lab review from today. We did a lab to try and do a range chart as well as an X-bar chart for the sample water bottles, and I'm going to do it again so that you have a good assessment of how to do it on your own. So first of all, the data. Each column is an observation. So we've gone to the factory, we've selected 8 water bottles, and we've taken them back to the test area, and we're measuring the number of milliliters at 8 a.m. for those samples. So we want to kind of get a sense of that and see how it's going. And then over time we want to see if we're still consistent, we're still on track. So first of all, the measurement that we're going to take, we're going to say how close to the mean are we. If I have a tab here that just kind of shows our outcomes, the target outcomes that we're trying to achieve. So this X-bar chart, that's going to show us some measurements that we can say we're on track here. Our mean is dipped a bit for those samples at 9. At 10 o'clock, there's a few more samples, a few more bottles have a little bit more water, and it kind of rocking and rolling like that a little bit. And then a little bit of volatility at the end, but we're still within those upper control limits. So that's an individual sample might be up here that's bringing the mean up, but the average is still within those bounds. So we want to draw these 4 lines. The top one is the UCL, the upper control limit. The purple is the bottom, the lower control limit. That steady green line, that's the grand mean. That's a consistent number. That's the average of the averages. And then for every sample we get at 9, 8, 9, 10, 11, 12, we average out those to see where we are. So we're going to get that. And that's going to just give us a sense of our sheet. So if I take you back to here, it's giving us a sense in the X-bar chart of whether or not we're drifting from the center, from that mean tendency, the center tendency. In this case, if we look back, we started to drift here a little bit. We're going higher, we're going off center, in which case we might be similar to this one. We've drifted. We're not actually similar to this one. We've drifted above, but we're still within the control limit. So that's the goal. The dispersion of the data, so the shape of that bell curve, might be completely normal. It might be just, perfectly averages out to be dead center, but it gets wider and wider and wider, like we're looking at in this case. And that's what the range chart's job is to do, is to tell us if we're getting wider in dispersion, less accurate. If you think of the paper jets, there's a few going backwards, there's a few going really far. There's more and more of those odd jets are not all landing in the same spot. That's what the increased dispersion means. We want 2 charts, a range chart, which is this one on the right, this one, a range chart that tells us if we've suddenly made, we've got an issue with our factory, we have a really wide dispersion, well beyond the limit of what we set as our standard, and we need to deal with it. So that's an opportunity to go and investigate and see what's happened. And then the X-bar chart, which you've seen before, is measuring that mean tendency. Are we still on average the same? So we'll go and we'll create both of those. So these are just images. I don't have them. They're not live. So if I take this live data here, the first step I want to do is get that mean. That's the number we're going to plot. That number as we go across here will be those lines that we plot right here. That blue line. Plot, 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 plot. Each point. I'm going to call that just the mean. Alright, and I'll put a bar. This is the number we're going to plot that number. I'll put everything that we plot right here in blue. That'll be the color of the bar, the blue bar. The grand mean, that green line, is the average of that bar. I'm going to make that a green. We're going to average of those numbers. That green. So that's that green bar in the middle. And then we have an upper control limit and a lower control limit to assess. And there's 2 ways to do it. We can use the approach with the sigma, or we can use the approach with the min-max and range. So I'm going to do that one. I'm just gonna, max is usually higher, max, min. So that minimum that we're taking is per sample, the minimum of these ones. Sorry, that's a max. Sorry. It's a max of those, and the min is the same. And we're using these figures to try and calculate those control limits. So the difference between them, that's the range, equals this minus this. That's the range. So there's 15 milliliters between the least filled and the most filled bottle at 8 o'clock on that day of the samples we took. That's going to be used in the calculation for upper and lower control limit. We can calculate and drag that over. We're still not plotting any of this. These are just used to derive other values. So I'm going to call this one grand mean x double bar, or x bar bar, or grand mean. This one is going to be called r bar. That's the average of those ranges. That's going to be used in our formula. Of UCL. UCL equals grand mean plus A2 times R bar, which is that one we just derived. LCL, grand mean minus A2 times R bar. So then the number we're going to get here, these numbers, these are going to set the targets, the red line and the purple line. So I can make that red in a second here. I'll make it a red line, red, and that'll be purple. Those will be the top two lines. I'll make it white. So the grand mean is that green one, O13, plus A2. We have to look up A2. We'll get that in a second. Yeah, we'll look it up now. That's from our table. We have 8 samples, so A2 in this column is 0.37. 0.37, and then times the average of the range, times this value here. Forgot to get it. So our average range is 15 milliliters from smallest to minimum for each sample we've gotten. That means that's going to put our upper limit at 505. That's going to be put it right around here, 505. And the lower limit, the purple one, is the same formula. Minus A2, 0.37 times the average range, 493. And you can see it's 493 point something here. So those will be our two values. So we've got everything we need to plot. We just have to put it in the shape of something that's easy to plot. So we need that line, that in a line, and these three things in a line. So these single values, we'll just make them, we'll just copy them all the way down. So I'm going to say the mean. These are this is the one that's going to move around on us. That's the blue line. I can copy this over. Copy, paste special, transpose, and paste. That gives me those values. What's going on here? Better. So I paste the values, not everything, because I was pasting formulas and that got crazy. So paste the values and transpose. So that's our blue line. I'm going to plot that, make it nice, pretty blue. And then upper control limit, that'll be our red line. The lower control limit, that'll be our purple line. And the grand mean, or x bar bar, that'll be our green line. So it equals this one. Upper control limit is that one. But since we're going to copy all the way down, we're just going to fix that row so that as we copy it doesn't drift on us. And the same thing here, equals this one. I'll put a little dollar sign before the number so that as we copy it doesn't change as we do that. And the same for this one. So we should be able to plot that and produce a chart that's very similar to what we had as a target. That looks good. I'm going to move it over here, and that'll be our live version of that chart. And so as we change, if I go back and change, let's say, the variance of that, let's see why that went so wild. Some of these observations had a big range, so you see that 52 is a fairly wide range there. That influenced our movements a little bit. Looks like it might have been this one. If I were to just drop that down to 500 just for a second, what would we'd expect that last line to kind of wiggle back a bit, as it did here. It's moved the limits a little bit, and it's moved everything, I guess, but it's still at a kilter. And we could go and tweak a few other ones here. Maybe drop that one to 500, let's say. We'll go back and fix it in a sec. And that should cause these to adjust. You'll notice our upper limit is shifting as we go, so now it's in the 503, whereas before it was 504. It's sensing that standard deviation. It's sensing that movement around, and those upper and lower control limits are self-adjusting to the data that's there as we go through. So I'm not smart enough to see the obvious fix here to make that go down and level it out, but it is adjusting the thresholds, and I could play with the data to flatten that curve a bit, basically just making all the data as accurate as possible, as close to the mean, the overall mean of 498 as possible. If I put 498 in all of these cells, I'd expect some fairly flat lines. I'm just going to undo that though for now. So upper control limit, I'll make that a color, that's red. Lower control limit, that's a purple. I'll make it a purple here. And the grand mean was green. And that's our line. Those are our lines here. So now we want to create a range chart, and the range chart is different. That's measuring not the center line, that's not measuring the number of milliliters, it's measuring the difference between the lower and the maximum, the fluctuation or the dispersion of how accurate that is. Ideally, the range is 0 all the way across. We don't want any difference between every bottle. That's the ideal case. Of course, it's not always the case, but if that was as close to 0 as possible for all these values, the min and max would be the same. They would all be equal to the average min and max in that case. So let's try and plot that data as well. So if we think about it, our blue line here, that is the range now. It's not the actual number of milliliters that are in the sample. We're not going to plot that one. We're going to plot this one. We're measuring dispersion. If we go back to the slide, we're measuring how wide that is, the average dispersion. Not where it is, not in this case where it is on the middle line, not drift, but dispersion. Different measurement. So range UCL and LCL. D4 times R bar. And then LCL equals D3 times R bar. So if we look up in the same number, we have sample size of 8. We look up, I think, yeah, 8. We look up in that sheet, sample size of 8, we're looking for D3, D4, so 0.14 and 1.86. D3 is 0.14, D3 0.14, and D4 1.86. So these were fixed constants that we looked up. They're based on the sample size, and they've been pre-calculated for us. So in this case, the upper control limit equals D4, this one, times the average range, this one. Fairly easy. Oh. And that's not 505, that's 28, and the other one's somewhere around a 2, I think, equals D3, different figure, times R bar, a 2. So those are the upper and lower control bands. Those are the red and the purple. These two columns. And the green, the one that we're plotting as a center line in our target, this line, is the average of the ranges. It's R bar in that case. This one. That'll be our new green. And this will be our new blue. We want that blue line right here. We're going to plot that one. That'll be the fluctuations that we're measuring in our samples and in terms of dispersion. What we notice here is that, oh no, all of a sudden we were doing pretty good within our range, and then now that everything, we're overflowing or underflowing quite a bit. Maybe a new employee or something, they're not doing an accurate job, not nearly as accurate as the past. So we want to try and get that plot out. Sorry, we're going to measure range, UCL, LCL, and R bar we'll call it the average of the ranges. So that's this value here. We're going to copy that. Right click special, paste special, select values, and transpose. That'll work for now. Upper control limit will always be fixed, equals this one. Lower control limit will always be fixed, equals this one. And the R bar will always be fixed, equals this one. We're going to put a $sign in front of each of those. And we're going to drag those down. Sorry for my pop-ups. So this is what we want to plot for the range chart. Insert range. And that will look very similar to the other one we had, other than the colors. And now we know that we're in control. For the first one, our shape of our curve is in control. We're consistently producing regular patterns. Our mean is, maybe we're improving, our mean is changing or drifting. but we're not necessarily in control in this case. We found a sample that's outside that. We might want to create a little indicator light or something that says we're no longer in control. We can do that fairly easily with like a count if. I'm just going to delete this one. We want to know if any of our means for the first bar, any of our means count if this range is greater than our upper control limit. We can do the same thing again. Our means are greater or less than our lower control limit. And then note we're looking pretty good. We're in control in that case. We could do the same thing here if our any of our sample ranges are outside or greater than our upper limit. We should get a 1 here, and we should get a 0 for this one. Less than lower limit. And this one is red, for example. So we have an anomaly to go investigate. So if I were to build a dashboard of our factory and we just want to watch, you know, and I don't want to watch a target that maybe moves a lot, we don't always see it. I just want a flag. That could trigger some kind of event. Some code could say if it's ever a 1, go do something. Stop the bus, whatever event you want to trigger, it could be used for that. Alright.